All right, okay, here it goes. I don't even know if this is on me. Exponent rules. First off, start off by saying remote teaching, not my favorite. I miss you guys a lot, and I really can't wait for next school year when I'm not talking to a wall and a bunch of chairs on tables. This is awkward. I'm feeling a little awkward. Algebra 2, exponent rules. So you got product, quotient, power to power, power of 0, and then talk about how to distribute some exponents. Might make a mistake. My students know I make mistakes, so bear with me. Product of product. So, talk about some vocab first. If I have x squared times x cubed, bases. All right, so my bases would be x would be my base. And my powers would be those would be the powers slash exponents. Okay, so the important thing is they have the same base. All right, if they don't have the same base, you can't do this. If they have the same base, then the rule, the product rule, the first rule we're going to talk about is you can add the exponents together, and you'll get x to the 5th. All right, this would not work if I had something like a squared times b cubed. Not same bases, not the same. All that does is equals a squared b cubed. Not the same bases. Same base, not the same. Product rule applies, product rule does not apply. They have to have the same base. All right? Quotient rule, I'm gonna go through this pretty quickly because I'm gonna post notes for my students. Quotient rule, we have, let's say x cubed over x squared. Quotient, division, now notice again, same base. I got a base of x and a base of x. That means that I can do the rule. All right, so the quotient, well, product and quotient are opposites of each other. All right, so if product was addition, hopefully you can surmise that quotient would be subtraction. So this is equal to x 3 minus 2. All right, the numerator's exponent minus the denominator's exponent. So you get x to the first, or you can just write x. All right, same base. Subtract the exponents, top exponent minus bottom exponent, and then you get, well, you simplify it, and you get your answer. All right, again, if I had, I don't know, w to the 4th over z squared, I can't do anything with that. I'm not gonna rewrite it. I can't do anything, not the same base. Can't do it. Same bases, subtract the exponents. That is the quotient rule. All right, product, add exponents. All right, quotient, subtract, say, subtract bottom from top exponent. All right, now we got the power of power, and I really hope this is all showing up and I'm fitting in the frame. Taking this on a freaking phone. All right. Power to a power. So that would be if I have something like x squared to the power of, let's say 3. So we've done addition, we've done subtraction. Hopefully you know what comes next. All right. So what comes next would be multiplication. So you're just gonna multiply. Let's do 2 times 3 equals x to the 6th. You multiply the exponents, or the powers. Exponents, powers, interchangeable, you multiply them. All right? That's that one. I'm actually gonna skip to distributing powers next. All right, so power to a power, multiply exponents. I hope this is visible on this video. I have no idea. Hope I can even upload this thing. I'm about to figure out YouTube. All right. Distributing powers. So write this example up here again. I had x squared to the 3rd. Technically, I didn't draw it, but technically I distributed that 3 to the 2. All right, but what if I have more bases inside the parentheses? What if I have, I don't know, let's say a squared, b cubed, and all of that is to the 5th? Well, now it makes more sense to actually show the distribution, because there it was just, I gotta multiply the 3 and the 2. Here, I need to distribute the 5, the 5th power, power 5, to both of them. All right, so that would give me a 2 times 5 and b 3 times 5, which would simplify to be a to the 10 and b to the 15. All right, distribute powers. All right, power to a power is technically, you're always going to distribute it to all of the powers, that one is to the power of. A lot of powers. Okay. Same thing works on, right, we did product, that's a product example. You can also do a quotient to a power. So, grab this eraser again. Quotient example, so if I have, let's say, w squared over x cubed all to the 3rd power, all right, you also distribute the 3 to both of the exponents. All right, and that would be w 2 times 3, x 3 times 3, which would equal w to the 6th over x and 9th. And again, I can't do the quotient rule with this one because they are not the same base. I cannot simplify this. This is simplified. That's as far as it goes. All right. Oh, I forgot a rule, very important one. But let's do power of 0. All right. If I have x to 0, that equals 1. If I have anything to the 0, that equals 1. Really easy to do some quick math and make a hard-looking problem simple if there's something to the power of 0, because that makes it all become 1. That one helps out a lot. Some of the problems I'm going to assign, that quickly eliminates sometimes an entire problem if I'm trying to trick somebody, a student, and I just throw little brackets, parentheses around it, put a little 0 up there, whole thing, 1. So anything to the power of 0 is going to be 1. Now the one I forgot to write over here, write it up here, 6th rule, negative power. And it's right here, makes it 1. All right, negative power. Negative power is going to flip, make it the reciprocal, flip it over the fraction part. So if I have x to the negative 1, that equals 1 over x. I know this one tricks some students up sometimes because they're like, there's nothing to flip it over. Whenever you have something, we are lazy mathematicians and we don't write everything that's actually there. Anything is always over 1 because it doesn't change it. You can divide anything by 1. So I flipped it. And technically, right, this was to the negative first power. This is still to the first power. The degree didn't disappear. It just became positive. -1, +1, it's on the bottom. Same thing as if I start with a fraction on the bottom, well, I'm going to flip it to the top. And I don't want to write all this because, again, I'm lazy. I would have just wrote x because now it's on top. It's on top of the imaginary 1 right there. And I don't need to write to the first power because that's just x. That is x to the first power. Better example might be if I use something other than 1, I guess. Let's say I have w to the -2. That equals 1 over w to the +2. Because remember, there was that imaginary fraction bar with a 1 on the bottom, and I just flipped it over. I made it the reciprocal, and the exponent didn't disappear. It became +2. All right, -2, +2 on the bottom. Same as if I had 1 over r to the -3, flip it, and that becomes r to the 3 on top of the imaginary 1. But I'm not going to write that because you don't need to. All right, that's simplified. Hopefully this helps my students with their homework that I'm going to send. And hopefully I don't look like a dork and I can't, a little awkward. I feel like I'm making like a first vlog or something. All right.